So today we're going to be tackling one of the bigger theorems of differentiation, probably the most important theorem of differentiation you should probably be familiar with because of its applications that we'll use in later theorems that we do, like trig derivatives and exponential and log derivatives. And that is the chain rule. Now the chain rule, even though I express it like a rule, express it like the power rule and stuff like that, it really truly is expressed as a theorem, and so I'll go through it as a theorem. So if you have two functions, you have y is a function of u, and u, that same u is over here that was used as the independent variable in the function of y over here, that same u as a function of x, and they're both differentiable. You know you can differentiate both of these. Well then, if you want to take the derivative of the composite function of these two functions, then you can take the derivative of the outside. So you can take the derivative of the outside, as you can see right here, but keep the inside the same. As you can see, the inside is still the same as what it was before. Keep the inside the same, and then multiply it by the derivative of this inside. Another way you could do it is you could think about it using a method called u substitution. U substitution. And because you're using u substitution, you can then take the derivative. This inside basically becomes equal to this u. The inside is just equal, so this would just become this inside would just become u, and you would take the derivative with respect to u, and you'd take the derivative of that u with respect to x, and then you'd multiply those together, and you would be able to get dy dx. And the reason u substitution works like that is because when you have two fractions like this multiplied together, you know that these are going to end up canceling, and they're going to end up multiplying to 1, and then you'll be left with dy dx. So that's why u substitution works. I typically don't like to use u substitution. I usually prefer this method when I'm differentiating. It's not like either one's wrong. They're both correct and right. Teachers, I think, probably like to lean towards the u substitution versus this one. The reason being is because u substitution comes back up when you learn about integrals and integration. And with integrals and integration, the only way you can solve complex integrals is through u substitution. I mean, there's other shortcuts and stuff like that, but in terms of like multiple functions instead of a function, there's not like an easy chain rule kind of solution like this. It's more of a u substitution. And so teachers, I feel like some teachers would probably prefer you to do u substitution than this, but on the AP test, they're not going to matter. And I think that this one is more, the one that I have the smiley face by, is more conceptually easy to understand. And so I'm going to be using this method, the derivative of the outside, the inside remains unchanged, times the derivative of the inside, more than I do the u substitution. Now, I had a friend of mine come up to me, and he was like, you know, the easy way I remember the chain rule is I think of it like an onion. And I was like, oh, why? Because I don't know how to draw an onion. I don't think it probably doesn't have that top. It's probably got like frizzy frizz. I don't know. It's got, but I was like, all right, this is my onion. I'm making it, I don't know, I'm also just making it pink because I don't know what to make it. And I was like, why an onion? Does it make you cry a lot? And he's like, no, when I take the derivative of the outside function, it's when I take the derivative, it's like I'm peeling off the layers of the onion. So I peel off the first layer of this onion, but just because I peel off this first layer of the onion doesn't mean that the inside of this onion right here is changing. This is actually not, it's not like the DNA is actually changing inside this onion. The DNA is still the same. And that's kind of the idea with the chain rule is you're peeling back the layers until you get to the middle of the function. And when you peel off each layer, you're not actually changing what's inside the function. You're just peeling off the derivative of each layer as you get to the center without changing whatever is inside, whatever is in the center. And so that's an easy analogy for you to think of the chain rule. But I think let's keep going, and let's go ahead and do a couple practice problems. So the first one, I think we'll just do one practice problem and then call it a video. So this one is find the derivative of this function. Well, again, we have, this is our outside function. We have this whole function is being raised to a power. But the problem is inside that power, we have a linear function. This linear function is getting raised to the 10th power. So this calls for the use of the chain rule. So I'm going to say that y prime is equal to, we're going to peel off that layer of the onion. the furthest out layer of the onion, that's this power right here. So we're going to do the power rule on this whole thing. So we're going to bring the 10 down because that's the power, and the power comes down to the front. But what we're going to do is we're going to leave the inside unchanged. So we're going to keep inside, we're going to keep that 3x minus 5 the same. And we're not going to do anything to it. And just like normal power rules, we've got to reduce that power by 1. And then we're going to multiply by the derivative of the inside. And so we're going to take a look at this inside here, and we're going to be like, all right, well, the derivative of a constant is just 0, and the derivative of anything multiplied by x is just that coefficient. So we're just going to multiply by 3. And that's all. That's the calculus. That's the chain rule. After that, it's just simplification. And I noticed that I can multiply this 3 with this 10 and get 30 times 3x minus 5 to the 9th. That's my application of the chain rule. And so I am done. This is the correct answer. And that is how you can use the chain rule on, this is just how to use the chain rule when you take derivatives.